Okay, so today it is metallic bonding time, and we're going to be looking at how to draw it. We're going to be looking at what causes the bond, and we are, of course, going to be looking at properties of metals. And remember to download your copy of this PDF so you can be making your own revision notes as we go through. So let's get started. So how to draw a metallic lattice? Well, here we have what AI thinks a metallic lattice looks like after lots of help with its prompts. And yeah, this is great. This is pretty much kind of what it looks like in 3D form. You don't need to draw in 3D, you need to draw in 2D, as we will get on to in a bit. So let's add some information to this. So yeah, with the lattice we have, our positive metal ions arranged in a regular way. So this is what the word lattice means. Again, we've seen this word before. Lattice just means regular arrangement. And yeah, we've got our regular arrangement of positive metal ions. So we've got our positive metal ions, and then we can see, maybe not, but we can see we have some electrons. So electrons we have kind of dotted around here and there, kind of, yeah, like these little glowing dots. Thank you, AI. So these are the electrons. And yeah, these are the delocalized electrons. So these electrons are free to move throughout the lattice. So yeah, it's called a sea of delocalized electrons. So what does this look like when it comes to a 2D image? So what you need to do is you need to draw, as best as you can, a nice lattice. So a regular pattern of positive metal ions. So we can just draw some circles, put some positives in there. So here we have our regular lattice of positive metal ions. And then the second thing we need to do is we need to show our electrons, and we can just show the electrons as dots. These are our delocalized electrons, that are free to move. So there we go, nice and easy. All right, so now what causes the bond? So here we have our definition. And we have our key part here. So the electrostatic attraction. So we've seen this with all three bonds. It's always an electrostatic attraction. And it's always between something that's positive and something that's negative. So it's just the positive and the negative thing that changes each time. So let's see what it is this time around. So we have a strong electrostatic attraction between the positive metal ions and the sea of delocalized electrons. That is where the bond is coming from. And this is what AI thinks that looks like. So not great, but we have our metal ions. And then we can maybe say these are the electrons. And here we have the attraction between them. So yeah, so that is what is causing the metallic bond, the strong electrostatic attraction between the positive metal ions and the sea of delocalized electrons. Okay, nothing too tricky about that. Okay, so now on to the properties. So again, the properties are always linked to the type of bonding. So our first property is malleable. So metals are malleable. And what does that mean? It means you can hammer them into shape. So unlike ionic and covalent compounds, if you start hammering them, they're just going to break. They're going to break apart. But with the metals, because of how they bond, when you apply a force, you kind of disrupt the lattice. When you stop applying the force, it then keeps the new shape. So this is the really great thing. So you can hammer it into shape, as I'm sure you've seen with metals before. You might have seen your metals get dented. And this is, a force has been applied, it changes the shape. As soon as you stop applying the force, it then keeps the new shape. So here we go with our lovely hammer, smashing up some gold. So yeah, gold, little bonus fact, gold is the most malleable metal. Means you can just keep changing its shape, and it's actually never really going to break. Okay, what do we have next? So metals, non-surprisingly, conduct electricity, and this is what AI thinks is going on. So yeah, we've got our positive metal ions, and we have our electrons. So we've spoken a lot about why do things conduct electricity. So for something to conduct electricity, you have to have a charge carrier. So metals have that sea of delocalized electrons. They're free to move, they can carry a charge, and that's why they conduct electricity. So this is why metals are used as conductors in wires, because they're very good at conducting electricity, so they have very minimal resistance. So there we go, a nice, quick and easy video for you today. So yeah, thank you for watching, and if you enjoyed what you've seen, please tell all of your chemistry friends, like and subscribe, and if you need even more help, even more chemistry help, then check out my website. The link is in the description, and then from there you can arrange some chemistry tutoring. Okay, so thank you again, and yeah, ciao, bye bye.